Hello everyone. In this tutorial video, I'd like to introduce factors within the fluid itself that cause turbulent flow, as well as how to predict when exactly the flow will stop moving in straight lines and become turbulent. As mentioned briefly in the previous tutorial video, obstructions in a flow and high speeds in a flow will both cause turbulence. As you may have noticed, if you ever went to the doctors and studied how narrower arteries cause more turbulent blood flows, because the entrance to the artery is irregular, i.e., it has a bumpy curved entrance that deflects part of the fluid so that there are velocities that are not part of a straight line flow. A non-medical example of this is in faucet taps, as the sharp corner in part of the faucet tap's conduit will also cause irregular velocities that are not part of the overall direction. There is actually a mathematical tool that many engineers use called the Reynolds number that helps you easily predict whether the flow will be straight line throughout or will have some turbulence in it based off the value. However, the Reynolds number only works for pipe-like conduits, so it will not account for things like blockages or other obstructions. An informal definition of the Reynolds number is the ratio of inertial forces to viscous forces, but a more precise definition is 2 times density times velocity times radius all over thickness, where velocity makes sense right away based off the definition given earlier, and density and radius may be a little more confusing, but we know a more dense fluid is more massive, so it has more inertial forces to it, and that by similar logic, a tube with a wider radius will have a greater amount of fluid overall within it, aka more mass or molecules of the fluid. And we know, by the definition of mass, is that it is the measure of an object's inertia. Based off of plugging in this formula, if the value returned is less than 2000, the flow will have no turbulence in it. If the value returned is between 2000 and 3000, the flow will have some turbulence in it and may even randomly oscillate or move back and forth between straight line and turbulent flow. And if the value is greater than 3000, the flow will be mostly turbulent with almost no straight line flow. You can see for yourself that this is true by experimenting with water, i.e., by opening the valve in your sink to different levels. You will notice at the very beginning it will be straight line flow, but as you open the valve more, it will randomly oscillate between straight line and turbulent flow, because it will look like that it randomly changes direction of the flow at that particular point. Finally, when you have the radius of the flow very wide because you open the valve very wide, you will see that the flow is basically turbulent all around if you look closely. Now that I've explained how turbulent flow is caused by factors within the fluid itself, I can explain how solid objects cause turbulent flow, even if the fluid is stationary, and how the resistance caused by turbulent flow is called drag. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.